All right, guys, today we're going to talk about events involving and conditional probabilities, okay? And what I mean by that is we're going to look at what's the probability of one event happening and another event. Last time we looked at the probability of one or the other happening, so as long as one of them happens in the last section, which satisfied. But now we're going to find the probability of, for example, two things happening. Well, events can either be independent events. An independent event we define here, as you see. Two events are independent events if the occurrence of either of them has no effect on the probability of the other. So, two independent events. The probability of a tornado hitting Saginaw on Monday, and then the probability of a tornado hitting Saginaw on Friday. Those are independent events. Those events, if a tornado hits on Monday, there's not any higher or lower probability it'll hit on Friday than there was before that hit. So those events are independent. Okay, an example of dependent events is when I say, what's the probability of drawing two kings out of a deck of cards in sequence? So, well, what happens is the probability of pulling one king out, the first king, is 4 out of 52 because there's 4 kings. But now that that card's out of the deck, if I didn't replace it and put it back in there, then the probability of pulling out the second king is there's only 3 kings left and there's only 51 cards left, so that'd be 3 out of 51. So those two probabilities are dependent because the second probability depends upon the fact that we pulled the first one out or didn't. We pulled a card out. Now, if I replace the card and then draw the second one, then the probabilities are the same each time, and those are independent events. So the probability of two independent events happening, A and B, right here, is you just take the probability of one and probably the other and you multiply it. Okay, this isn't super hard. So let's do an example. Okay, so find the probability of green occurring on 2 consecutive plays on a roulette wheel. Well, this is independent because when I roll the roulette wheel and then I start over, the probabilities are all the same. It's a whole new reset. So they don't affect one another. It's not that we pulled a card out of the deck and we have less cards to choose from now. So there are 18 black holes on the roulette wheel. There are 18 red, and there are 2 green, for a total of 38 places the ball can land, the roulette ball on the wheel. Okay, so find the probability of a green. So the probability of green and green, so 2 greens, would be 2 out of 38 times 2 out of 38. We just multiply the two probabilities. It's a 2 out of 38 chance on the first one, 2 out of 38 chance on the second one. So that's 1/19th times 1/19th. If I reduce those two, and 19 squared is 1 out of 361. So this ends up being 1 out of 361 is the probability of getting 2 greens. So it's pretty low. Okay, so that's how we deal with independent events. Okay, let's look at this one. If the probability that South Florida will be hit by a hurricane in any single year is 5/19. Okay, so again, what's the probability that South Florida will be hit by a hurricane in 4 consecutive years? Well, that would be the probability, I don't know why I'm writing that, sorry. Probability of hit and hit and hit and hit. So we're going to find the probability that it hit 4 times in 4 consecutive years. These are independent events. The reason they're independent events is because whether or not a hurricane hits one year doesn't depend on whether or not it hit last year. Those events don't affect each other. So since it's 4 ands, we just multiply the probabilities. It'd be 5/19 times 5/19 times 5/19 times 5/19. And if I plug that in my calculator, I can plug it in my calculator as... The way I can plug this in my calculator is I can put a parenthesis and do 5 divided by 19. This is what I'm typing on the calculator. So parenthesis, 5, use the division sign, 19. That turns it into a fraction. And then do the little up caret, which is your exponent. Raise that to the 4th power since we're multiplying it by itself 4 times. And then you can hit and do a 4. And then you can hit the math button and select frac, which is the first choice. So hit math, and then frac is number 1, so hit enter, and then you hit enter. And it doesn't want to change that to a fraction, but I'll give you the answer. So this is part A, sorry. You get 0.0048 is the probability. So it's super unlikely that it's going to hit in 4 consecutive years. Okay, so that's part A. Let's erase a little bit of this. Part B, what's probably self-4 will not be hit by a hurricane in the next 4 years. Okay, so, well, we first say we know that the probability that an event happens, so the probability of not hit in a year is going to be 1 minus the probability that it hits, right? We talked about that last section. So the probability that it's going to hit is 5/19, then the probability that it's not going to get hit is 1 minus 5/19, which is 19/19 minus 5/19, because 1 is 19/19, which is 14/19. So the probability it's not going to hit, the probability of not hit, and not hit, and not hit, and not hit in 4 consecutive years, I would multiply 14/19 by itself 4 times. And then I do that in my calculator. I get 14 divided by 19 to the 4th power. I get 0.295. So you got a 29.5% chance that it's not going to hit in 4 consecutive years. All right. So let's look at part C. I'm going to clear this. I'm going to erase some of this stuff. Actually, for now, let's skip part C because it's going to be, there's another problem we're going to do a little bit that's going to like address this kind of idea a little bit better. So let's skip C for now. And let's erase this thing. Okay. 2 events are dependent if the occurrence of one of them has an effect on the probability. I gave the example of the cards earlier when we were pulling out 2 cards. And once I pull the first card out, if I don't replace it, then if I don't put it back in for the second draw, then I've changed the probability potentials because I've taken out a card. So there's 51 on the deck now. So my denominator, my probability will now be 51, for example. And probabilities of dependent events is I take the probability of the first event, multiply by the probability of the second event, given that the first event has occurred, because now that first event affects the second event. So let's do an example here. I'll make this a little bit easier. So look at part A here for a second here. You were dealt 1 card from a 50-card deck. Find the probability of getting a black card, given the card you were dealt is a spade. Okay, so find the probability of getting a black card, given the card you were dealt is a spade. Actually, this is a mistake. I'm not supposed to do this problem yet. I'm supposed to do it next. So let me erase that problem quickly. So let me get that out of there. And let's get the right problem in there. Okay, you dealt 2 cards from a 50-card deck, the probability of getting 2 kings. Okay, so we've talked about this example before. So let's get the right color here. So the probability of king and king, these are dependent because when I pull the first king out, I have less cards in the deck. So the probability, so that'd be a probability of king number 1, okay, times the probability of king number 2, given, sorry, my bad, given king number 1 drawn. Okay, that's what this formula is saying up here. The probability of A and B is the probability of A times the probability of B, given that A has occurred. So let's take a look at how that plays out. Probability of drawing king 1 is 4 out of 52. We already talked about that. Times, now that there's only 51 cards on the deck and there's only 3 kings, that would be the probability of king number 2, given that king number 1 has already been drawn. Okay, so that gives me, just doing the calculator, 4 divided by 52 in parentheses, times in parentheses 3 divided by 51, math frac to get it into frac form, 1 out of 221. So there's a 1 out of 221 probability, dependent probability. Okay? All right, so that's a very simple problem. So let's clear this slide. So if we have two dependent events, we have what's called a conditional probability. The probability of event B, assuming that the event A has already occurred, is called the conditional probability of B, given A. This probability is denoted by this, P, B up and down A. This means the probability of B given that A is something you're aware of. Okay? So A has already occurred. What's the probability of B? So let's look at this problem. You're dealt one card from a 52-card deck. So you're just getting one card now, okay? This is important. Find the probability of getting a black card given the card you were dealt is a spade. So basically what they're saying is, guys, you know the card you got is a spade. So that's something you know. That's information you have. So basically what's happening is I'm restricting my sample space to the fact that you've gotten a spade. So let's say I tell you you have a spade. What's the probability of getting a black card? Well, isn't the probability of getting a black card when you know you had a spade 1? Well, there's 13 black cards, and you know that you have a spade, so the probability is 1. So answer A is 1, because since you know you have a spade, so let's say I hand you the card, and you put it face down, you don't look at it, and I tell you, there's a spade, it's definitely a spade. Then I ask you, since you know it's a spade, what's the probability of getting a black card? You're like, well, of course it's a black card if it's a spade, because all spades are black. Okay, part B is a little trickier. Find the probability of getting a spade given the card you were dealt is a black card. Okay, so the way I'd write this one is that this would be the probability of getting a black card given that, using this notation right up here, given that you know it's a spade. Okay, so now let's do the second one is the probability of getting a spade given that you know you were dealt a black card. Okay, well, not all black cards are spades, but how many black cards are there? Well, there's 26 black cards, my bad. So there's 26 black cards, correct? So you know it's black, so you know that you're choosing from 26 cards. And now you want to find out whether it's a spade. Well, how many spades are there that are black? Well, half of those are spades because there's only spades and clubs. So it's 13 out of 26. So that'd be a 1/2, 50-50 chance. Okay, so this is when one probability is conditional upon another piece of information. So you're restricting the sample space that you're choosing from. So in here we restricted the sample space to spades. And if I want to find out how many spades, I know I have spades, I want to find the probability of it being black. Well, it's 100% probability because all the spades are black. And then the second one's pretty self-evident. I like this statement from the book. It is helpful to think of the conditional probability as the probability that event B occurs if the sample space is restricted to the outcomes associated with the event A. So the example we just gave is we're basically saying we're only choosing from the spades in the first example. We're only choosing from the black cards in the second example. And that gives us a little bit of a condition upon what the probability is going to be. Okay, let's hit up a couple examples from the book. Let's look at number 16. You draw one card from a 50-card deck, then the card is replaced in the deck is shuffled, and then you draw again. It's important that the card is replaced. The reason why it's important is because if I draw a card out and then put it back and draw again, these are independent events because I haven't reduced the number of cards in the deck and I haven't reduced the number of, say, kings in the deck. And so these are independent events. So look at number 16. A jack the first time and a club the second time. And since we replaced the card in the deck, these are independent for events. So probability of jack. Whoops. And club is going to be the probability of a jack times the probability of a club. So the probability of a jack, there are 4 jacks, so that'd be 4 out of 52 times a club. There are 13 clubs. So this is 1/13 times 1/4, which is 1 over 52. Okay. Okay, in exercises 456, the number discs shown are placed in a box and one disc is selected at random. So you're going to grab one disc out of these. Let's look at number 50 first. what's the probability that of selecting a 7 given that a yellow disc is selected? So this is a dependent. So we want a probability of a 7 given that the disc is yellow. Well, let's look at that. It's really easy. How many yellow discs are there? There are 3 of them. So you know it's yellow. So there's 3 yellows. And how many of them now are 7s? Well, looks like there is only 1 7. So 1 in 3 chance, since you know it's yellow. Look at number 52. So this is 51. 50 rather, my bad. It's 50. Let's look at 52. Probably that's an odd number given that it's red. Okay, so my denominator is going to become, how many reds are there? 1, 2, 3, 4, 5. How many of them are odd numbers? Well, the 1, the 3, and the 5. There's 3 of them. So a 3 in 5 chance that if I know it's red, then it's an odd number. So it's just the red is the conditions, that's the denominator. Notice the yellow gives me my denominator and the red gives me my denominator. And then once I have that restricted, I look at how many yellow 7s there are and how many odd reds there are. Okay, this should get you ready for the homework.